This video, we're going to decide if a function is one-to-one, and if so, we're going to find its inverse. So the function f of x equals to 2x, you can graph it in your graphing calculator, but it's a linear function like so that's going to pass the horizontal and vertical line test. So the way we're going to find the inverse is we're going to take the function f of x, we're going to replace f of x with y. Then for our inverse step, these are not equivalent steps, but this is our inverse step. We're going to switch x and y. We're going to solve for the new y. We're going to replace that new y with the symbol f inverse of x. So y equals 1/2 x. We're going to write that as f inverse of x equals 1/2 x. If it's not one-to-one, then it's not going to have an inverse, so we can just try this process. And if it doesn't work, it's not a one-to-one function. If you can decide that it's not a one-to-one function before you start off, though, you don't have to try and find its inverse. Switch x and y. Solve for the new y. Like so. And that's our inverse function. F of x is equal to 7x plus 2. Make that y equals 7x plus 2. Switch x and y. Subtract 2, then divide by 7. And replace the y with f inverse. Rational functions can be interesting sometimes if they're constant multiples of the reciprocal function, because when we switch x and y, then we solve for the new y. We get the same function that we started off with. So this function is its own inverse. Now we've got a restricted quadratic, so that's only the right-hand side of the parabola. That is one-to-one. It's over here, like so. It's going to come across this line. It's going to be like so. So when we make it y equals x squared plus 4, and we switch x and y, x minus 4 equals y squared. This one was y greater than or equal to 4 for the range. Y equals the square root of x minus 4. This is my inverse function. But remember that my range becomes my domain and my domain becomes my range. So x is going to have to be greater than or equal to 4 here. X greater than or equal to 4. And y is going to be greater than or equal to 0. Y greater than or equal to 0, which means that I have chosen the correct portion of this plus or minus. I've chosen the positive square root on purpose because that goes with this range of my inverse function that y has to be greater than or equal to 0 because my domain up here was that x had to be greater than or equal to 0. So my inverse function here is the positive square root of x minus 4. It's restricted, so x is greater than or equal to 4. Y is going to be greater than or equal to 0. If f of x is equal to 5x squared minus 7, with x greater than or equal to 0, y equals 5x squared minus 7, switch x and y, x plus 7 equals 5y squared, y squared equals 1/5. Let's just do it this way, x plus 7 over 5. If x was greater than 0 in the original, y has to be greater than 0 in the final answer. So I want to choose the positive square root here. In this case, y was greater than or equal to -7. In this case, x has to be greater than or equal to -7, and y is going to be greater than or equal to 0. If f of x is equal to x cubed minus 8, then y equals x cubed minus 8. I'm going to switch x and y. X plus 8 equals y cubed. Y equals the cube root of x plus 8. That's my f inverse of x. No need to restrict my domain on this because it was an odd function. If we want to be sure though, let's go ahead here and say that my domain here was that x could be any real number. My range here was that y could be any real number. So my domain here is that x can be any real number. And my range is still that y can be any real number because my domain became my range and my range became my domain. (22) f of x equals 3x minus 1 over 8. So I'm going to y equals, I'm going to switch x and y. 8x equals 3, y minus 1. 8x plus 1 equals 3y. Y equals 8x plus 1 over 3. I'm going to replace that like so. And I have a domain of all real numbers here. And I have a range of all real numbers because this was a line, even if it didn't look like it. So there's no restrictions on my inverse function. Replace f of x with y, switch x and y. Make this 5xy plus 3x equals 2. Get the y term by itself. Divide by everything that's not y. And that's my inverse function, like so. You can see that this range was y greater than or equal to 0, or excuse me, y not equal to 0. This x was not equal to -3/5 for my domain. So my domain is going to be x not equal to 0. And my range is going to be y not equal to -3/5. There's my asymptote right there, because degree of the top and degree of the bottom are the same. So my inverse function here is 2 minus 3x over 5x. My domain is x not equal to 0. My range is y not equal to -3/5. F of x is equal to 5 over x plus 2. Replace f of x with y. Switch x and y. Solve for the new y. Again, up here, my domain, x not -2. My range is y not equal to 0. My domain down here is x not equal to 0. My range is y not equal to -2. F inverse 5 minus 2x over x. Domain of x not equal to 0, y not equal to -2. F of x is equal to x plus 5 quantity cubed, y x plus 5 cubed. Switch x and y. Take the cube root of both sides. Cube root of x is equal to y plus 5. Y is equal to the cube root of x with a -5 on the outside. F inverse of x is equal to the cube root of x minus 5. Careful that you show clearly that the -5 is on the outside. There's no restrictions on that. F of x is equal to x plus 2 cubed minus 8. Replace f of x with y. Now we're going to switch x and y. Going to solve for the new y. Take the cube root of both sides. Subtract 2. My inverse function is equal to cube root of x plus 8 with a minus 2 on the outside. Just a few more here. Yep. F of x is equal to the square root of x minus 1. Need to be careful here that the domain of this is going to be 1 to infinity. The range is going to be 0 to infinity. So we're going to have a restricted domain on our inverse. We'll replace this with y. We're going to switch x and y. And we're going to square both sides to get rid of the square root. X squared plus 1 is equal to y. My inverse function is x squared plus 1, but the domain has to be 0 to infinity. The range has to be 1 to infinity. Inverse of x is x squared plus 1 as long as x is greater than or equal to 0. (28) f of x is equal to the cube root of x plus 6. Replace f of x with y. Switch x and y. Cube both sides. Subtract 6. Inverse function is x cubed minus 6. There's no need for restrictions there because my domain was all real numbers here and my range was all real numbers here. So the inverse function was x cubed minus 6. And last but not least, 29, f of x is equal to 6x plus 7 over 3x plus 6. I'm going to replace f of x with y. We're going to switch x and y. Make this 3xy plus 6x is equal to 6y plus 7. This is more of an algebra 2 type problem where I've got y's on both sides. I need to get the y's on one side by themselves and the x's on the other side by themselves. That. Now I need to factor out a y. And then I need to divide. And replace y with f inverse. Like so. And you can find the domain up here. Let's say x can't be -2. And the range here is that y can't be +2. And you're going to see that down here, x can't be 2, and y can't be -6 divided by 3 is a -2. So the domain and range did switch here. This can't be -2, y can't be, sorry, this was positive, that's negative. There we go. And that's our last one for this section. Come back next time and start talking about exponential and logarithmic functions which have this inverse relationship. See you next time.